This presentation is to share about multimedia learning in games, simulations, and microworlds, an analysis by Lloyd P. Reiber within a greater volume. This chapter reviews and critiques the scientific evidence and the research methods that study the use of games, simulations, and microworlds as a multimedia learning tools in the educational setting. After this presentation, you'll have an understanding of simulations, games, and microworlds on their own and how they relate to student learning in the classroom. What is multimedia in games, simulations, and microworlds? This chapter is written to consider games, simulations, and microworlds within a broad framework for educational purposes. Most of the educational multimedia that's studied by researchers is interactive or experiential, but instead is part of instructional texts or presentations to explain content to students. So we have three different kinds of multimedia: games, simulations, and microworlds that we're talking about, and all three of these modes are vastly different from one another, but there is a value into using all three of them because some of them have benefits that accommodate the deficiencies in the other two. So using all three modes is something that is recommended. Multimedia that uses a multimedia explanation, for example, text, graphics, audio, animation, etc., those are designed to be viewed in one way and aren't really interacted with as much like a presentation like this, where you're getting all the information and you're seeing and hearing things, but you aren't really interacting with it. Game, simulations, and microworlds, however, are used in a different way, and that's where you build an experience through dynamic elements that are under the user's control. So the students kind of have control over their learning in these ways. We'll start with simulations. Simulations, when interacting with them, are something that the students must be able to first understand their goals and versus their intentions, and be able to judge whether or not their intentions have been met at the end of the simulation or when they're finished with their project. It's not something that is meant for novices because they really need to have some information already in that subject area before they can be successful in a simulation. Simulations are typically more graphical because textual design is not successful, and it usually requires teachers' guidance. So teachers have to give explicit direction for these, otherwise students will not discover the intention or the learning outcome. They are also very step-by-step. You can't move forward to a new skill until you've mastered a lower level skill. And what do we know about gaming? So gaming is conceptualized in two different ways. You can play educational games designed by others, or you can design your own game. And the research on whether playing games leads to learning is actually mixed, but it does provide data. The computer can log data about students' playing behavior: which game is played, how often, for how long, what level are they on, which things are they experiencing that they're mastering, and which things are they struggling with. Games should provide students with a quality storyline so that they can keep engaged. Competition: are they earning points? Do they have something to lose? What is motivating them to keep playing? And an appropriate challenge. So it can't be something that it's so difficult that they don't want to play anymore. The photo in the slide is from ST Math. It is a learning game that we use in our school, and it's an example of gaming. So it is directed by the game and their outcome. The students aren't creating it, they are playing it, and they have to compete with themselves in order to move forward. It also differentiates for the level that they are on, so it's an appropriate challenge. There are positive influences of a game on learning. They are usually pretty engaging, so there's a method of learning where the students want to learn more about the topic. It helps students focus their attention on the critical aspects of the content. So it really brings in their focus to certain parts of the content that they're learning. And it helps students organize information in a logical way. Finally, it provides students with a goal or an outcome. They have something that they're trying to reach, something that they are trying to accomplish within the game. There are also negative influences of a game on learning. It is not necessarily going to improve their test scores. In some research in a physics game, the research studies the students scored significantly lower than other students who did not use the games. So it doesn't always work just gaming on its own. Students can also become obsessed with the game and less with the learning, so they'll focus on increasing their score, but don't really understand why they are doing it, how they're moving forward, and the concepts that they are supposed to be learning. They focus more on the score that they're getting and how to get higher scores instead of understanding the learning that's going on, which leads to lack of reflection. So if there's no room for discussing or understanding how it relates to the content that they're learning in the classroom, then the students are less likely to understand and be influenced by the game in a positive way. So some examples from the article of simulations and games are these two. This is a Thinker tool, which is an online program which allows point-and-click methods to program a computer. Thinker tools allow students to learn about Newton's law of motion, and in the simulation, the user has control of the little black ball, but is able to change the velocity, acceleration, direction of the ball to experience and identify scientific terms. So these simulations can be programmed to exhibit any domain of education, not just science, but these ones are a little bit easier because science and math are a predictable computer language. And then the second is a snapshot of a game, which is textual, not graphical, and you can see why it might not be quite as desirable. But it's a snapshot of a computer screen that is running a game of Newtonian mechanics, where all the feedback is given to the user in numeric form. And finally, Microworlds. What do we know about them? They provide exploratory environments for students. They are very much student-led. And this allows for more access starting at a younger age. So students are able to understand and explore concepts of complex systems in simpler ways because they are in control and they are figuring it out step by step. They also focus on building and using actual concrete models, which gives the students more of a hands-on, if you will, kind of experience. So they are likely going to remember it more. They also have an easier to understand set of operations where students can engage in tasks of value, and they understand more powerful underlying principles. So they might understand ecology, for example, by building their own creatures that compete with and are dependent on each other in a world, so that they can see how that might work in the real world. In order to be in a microworld, they really have to have certain things. They have to model the principle that's being taught, and they have to have links to multiple representations of this model so the students have different examples to go off of. They also have to have the opportunity to combine the objects in complex ways. They need to be able to explore every avenue, whether they fail or succeed. And they have to have inherent activities and challenges to solve in the content area. So they have to be able to challenge themselves. And Microworlds solve some of the gaming's problems because they get to interact with real models that are built, pre-built, or that they can build on their own. And unlike a simulation, a microworld allows students to unlimited ways to construct models. So they have more flexibility in using a microworld. They also have their own control over the program oftentimes. So it's, like we said before, it's very exploratory. And they can be used in inquiry approaches. Simulation and games can as well, but they're definitely more directed. Microworlds are more inquiry-led. And as we kind of talked about before, it's kind of like an explanation versus an experience. So explanation-based media focuses on instruction of a particular content area, but experience-based focuses on the person's interaction in a content area and the relationship of that interaction to the person's prior knowledge. And learning is achieved in experiences through active engagement this way. We also have a similar depiction with explicit direction versus exploration. So if a student is going through a simulation, they will produce they can or simulation they typically produce explicit direction or a game. They will have instruction on exactly what they should be doing, and they don't have a lot of freedom. In exploration, they are given a micro world without any direction or guidance, and the purpose is to provide the student with the ability to explore and learn as much as they can through their own exploration. In that case, in either case, a question can still be posed, where the student is going to solve a problem or use the critical thinking skills to come up with an answer. But one in explicit direction is, as it says, explicitly telling the students what to do, and exploring kind of gives them free rein on how to solve the problem on their own. This kind of goes together with cognitive theory and learning through multimedia. So one of the ways that this happens is through the richness of interactive software, which simulations, microworld, and games. They are so many theoretical perspectives that you can use in trying to understand their role in learning and cognition, that two of them are talked about the most in this article. That's dual coding and mental models. We're going to start with dual coding. And you can see in the image that dual coding is a verbal and nonverbal system of processing mixed together, which means multimedia. So there's words that you hear and there's pictures that you see, and your verbal and visual go together and mix with your prior knowledge in order for you to understand and internalize what you are learning or what the students are learning. And that is a way that improves cognition and the learning process in one way. And the simulations, games, and microworlds definitely go along with this and sometimes add even more layers. Mental models are what someone's personal theory of a certain domain or environment is. So everybody forms mental models to help predict the systems that we confront in our environment. So a mental model is what we think of how something works or how something got to be where it is. And then those are reinforced through seeing a behavior, understanding the results, and adding it to our mental model again. In more simpler terms, a mental model is an explanation of someone's thought process about how something works in the real world. Like, I know that my house gets cooled down with air conditioning, but I might not realize that it's because the air goes through ducts and it comes out. I just know that there's something on my wall that brings cold air into my house, and it must do something inside of that. I may not know the intricacies of it, but a mental model is how I think that it works, not necessarily how it actually works. And this is something that relates to the multimedia because it allows the students to create their own mental model of how systems work. But because they are exploring it through a process that shows them technical ways that the systems actually do work, they are creating a mental model that is more accurate to the systems and codes and science and math that are accurate. And that is the summary of multimedia learning in game simulations and microworlds, with our reference from the article that we have summarized.